Hey, listeners, before we get into this episode, I have some fantastic news. My new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms, is coming out, and we are having a book launch webinar to celebrate. This book spans from kindergarten to 12th grade, explaining in detail how algorithms trap students and what we should be teaching instead.
Join us at this free book launch webinar and you'll learn what the traps of algorithms are, how to avoid them, and so much more. You don't want to miss it.
We'll go live on March 18th, 7 p.m. Central. Grab your spot at mathisfigureoutable.com/book-launch.
That's www.mathisfigureoutable.com/book-launch. We hope to see you there.
Hey, fellow mathers! Welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are amazing human achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop. And it can trap students into a digit-oriented perspective.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
Y'all, we invite you to join us to make math more figure-outable. Dun-dun-dun.
Hi there. So last week, 2 weeks ago, we started talking about your brand new book, Developing Mathematical Reasoning, Avoiding the Trap of Algorithms.
Oh, I'm so excited that it's out.
I know. It's so great. And so last week, we started talking about the first trap, a major trap that affects all algorithms, and that is the less sophisticated reasoning trap.
Yeah,
It's
huge,
rough. It's rough,
huge,
right?
So important. And you really have to understand the development of mathematical reasoning. You have to have a feel for counting to additive to multiplicative to proportional to functional to kind of then go, oh, wow, it can really trap kids into using less sophisticated reasoning than the problems are intended to develop. So that one's a little bit, kind of have to have some background. Y'all, today, let's dive into the second trap. I don't know if they're not in a specific order, but trap number 2, another trap that I think fits all algorithms. That it pick an algorithm and it can trap kids into this second trap. And I think this one, you actually can it doesn't take as much background to understand this trippy trap. We can go down this trip and get trapped okay, I'll stop. So today I'm going to do this a little bit differently than we did in the last episode. I want to do a problem string with you first and develop some reasoning and then kind of compare that to an algorithm and notice how the algorithm can trap kids how it can trap kids differently than what we just did in the problem string. So are you game for that? And then when we do that, then we'll talk about the trap afterwards.
Sounds good.
Okay, cool. So first problem, Kim, what is 56 minus 20?
That would be 36.
All right. So I've just drawn on my paper 56 minus 20. I wrote that problem down and then I drew a number line that started on 56 and I jumped backwards 20 and you said that would land on 36. So I finished the equation equals 36.
Yep.
Next problem. How about 56 minus 19?
So 56 minus 20 was 36. So I'm going to add 1 back to get to 37.
Yeah, but we're subtracting. Why are you adding?
Because I built off of the minus 20 and subtract 20 is subtracting 1 more than 19.
Okay.
So I'm adjusting by saying I'm going to add 1 back.
Yeah, you subtracted too much. Yeah, subtracted too much. On my paper, I went ahead and drew 56 minus 20 as that big jump of 20 back. If I were to have instead not jumped that big jump of 20 back and only jumped a jump of 19, it would have been a shorter jump, which means that the ending place would have been further to the right. And further to the right 1 for 36 is, like you said, 37. Cool. Next problem. 274 minus 100.
That would be 174.
And I've just drawn, you didn't need to do this on your paper. Nobody did. 274, big jump of 100 back and landing on 174. Cool. Next problem. 274 subtract 98.
So here's why it might have been useful to write it on your paper, because you could subtract 100 to get to 174, but then add 2 back to get to 176, because 100 was too much. So you can add those 2 back.
Nice. Cool. How about 563 subtract 300?
That would be 263.
So I've just drawn an even bigger jump back. 563 subtract 300. And it's not all that bigger because I don't have that big of a paper. But
is it bigger?
It's a little bigger. It's as bigger as it can get. And what did you say you landed on? 200?
263.
Okay, cool. Hey, Kim, do you want to guess what the next problem is?
We've done back 19. I'm going to go with, you wanted me to do 273. I mean, 297.
297.
Just making
that
numbers.
Was an excellent guess. Excellent guess. So we had minus 300.
Yep.
I'm actually going to ask you minus 295.
Okay. All right. So
that was a good guess.
Back 300 is too much by 5. So I'm going to add 5 back. And I got 268.
Because 263 and 5 is 268. Cool. All right. So if you jump too far back, then you adjust up because you subtracted a bit too much. That makes lots of sense. How about 7.2, 7 and 2/10 subtract 4?
So I'm going to call that 3. I actually thought about like $3.20. So 3 and 2/10.
Okay. And I've drawn 7.2 with a little jump back of 4 and landed on 3.2 or $3.20. How about 7.2 or 7 and 2/10 subtract $3.97? Hey, there's your 7. You're welcome.
Thanks. All right. So if I subtracted $4 to get $3.20, then I'm gonna $3.97 is just 3 cents less. So I'm going to add 3 cents back and get $3.23.
Because $3.20 plus 3 cents is $3.23. And to be clear, we often have kids kind of mess up the place value when they do that a little bit.
Yeah.
Which, let's just point out, is a brilliant opportunity for us to have a great conversation about place value.
Yeah.
Which I want to come up in just a second. All right, last problem. What is 8 1/4, 8 1/4 minus 5?
Okay, so that would be 3 1/4.
Okay. If 8 1/4 minus 5 is 3 1/4, what's 8 1/4 minus 4 3/4?
Okay. I subtracted 5. I'm adding another quarter back to get 3 1/2.
Because 3 1/4 and 1/4 is 3 1/2. Okay. All right, Kim.
Can I tell you that I was recently in a second grade classroom and started developing this strategy with them, and they were brilliant.
Oh, nice.
They could absolutely talk about why you would add a little bit back and kind of where the amounts were on a number line. I was so impressed with them. Just so proud.
Fun.
Yeah. It's really
fun.
great.
Huh.
Yeah.
So maybe keep talking. Like, could you look at the problems that we just did and kind of just talk about some
so
patterns you're seeing?
Yeah, you gave me kind of paired problems. And in the helper, the first one, subtracting a really nice friendly number. So like 20 and 100 and 300, even 4 was kind of a friendly number. Then those helper problems that I subtracted a little bit too much helped with we call it a clunker problem. The one behind it that is kind of a cranky number. So 56 minus 20 helped subtract 56 minus 19 because you could back up a little too much and then adjust. And then back 100.
Before you move on, can you keep that train of thought? Because I just want to interrupt you just a little bit.
Sure.
So to do that, you had to think about 56 minus 20 first. That's noteworthy.
Yep.
That you weren't just dealing with digits, but you were actually thinking about 56 and 20. Okay, cool.
The full magnitude of the number, the value of 20, not just 20. Yeah. So then when you gave me 274 minus 100, I could use that to help with 274 minus 98. So I was thinking about how far apart 98 and 100 were. So I subtracted too much and then added some back So I was thinking about 98 and how far away it was from 100 instead of 98 and 100.
Yeah, so it's not a bunch of digits. You had to think
Mhm.
about hundreds minus hundreds, and you had to think then about the connection or relationship between 100 and 98, how far,
Mhm.
and then which direction to go.
Mhm.
Cool. And then similarly, did you have to do something? I'm going to skip down to the 7.2 or 7 2/10 minus
Mhm.
4. Is
Yeah.
that where you lined them up, or is that where you butt cheek the decimal?
Oh, geez. No, I
Which rule? Which rule?
right?
Flip a coin, flip a coin.
Yeah.
Or were you, in fact, I think did you bring up money
I
first? I think
did. Yeah,
yeah.
I said I think about it like $7.20 minus
Mhm.
$4,
Mhm.
which made it nice because then when you gave me 3.97 or 3 and 97 hundredths,
Mhm.
then I could think about that like $3.97. And it's really nice to think about how far away $3.97 is from $4.
Yeah, it's
That feels
just
that feels
3
nice. Yeah.
cents, yeah, and
Mhm.
then you could just tack that 3 cents back on to
Mhm.
$3.20 that you had before,
Mhm.
and not like, again, like 3.2 and 0.03, am
Mm.
I lining?
Yes.
Am I butt cheeking? Like, how are these all related? Before we do the last problem, because I do wanna do that,
Oh.
I just wanna point out that in this problem, you just dealt with place value and
Mhm.
reasonableness and rounding and connections between numbers
Mhm.
and a sense of ish. Like, so Joe Bowler in her math ish book talks about get your ish number. And in a huge way, you were I was sort of providing for you an ish number.
Yeah.
And then you used that, but you had to think about the relationships between that.
Well, and I'm going to point out one more that
Okay.
when I was thinking about 295 and 300,
Mm-hmm.
I was thinking about the distance meaning for subtraction. Like I was finding how far apart 295 and
Ah,
300 were instead of, oh my heavens, 300 minus 295,
thinking about
borrow from a bunch of zeros.
oh, nicely said.
Ugh.
Oh, that was good. That was good. I hadn't even thought of that. Oh, that's good, Kim. I'll bring that up next time I use that example.
Happy to serve.
Yeah, because wait till you see where I'm going to go with that in just a second. Oh,
Okay.
that makes my next one even better. So then I kind of wish for the last problem that I hadn't given you the helper. I wish, very last one, 8 1/4 minus 5. I wish I had just given you 8 1/4 minus 4 3/4
Okay.
and asked you to come up with the helper.
Yeah.
That would have been maybe a better teacher move on my part. So do you mind if I just give you one extra problem
Sure
if we
enough.
were kind of doing this?
Hmm.
So let's see. What if I were to ask you something like 6 1/5 minus 3? No, minus, yeah. Sorry,
Minus three
sorry.
and
Blah, 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 blah. 3 4/5. So
minus three and four fifths.
6 1/5 minus 3 4/5. I
Okay.
wonder if you could help me come up with a helper problem for that.
Yeah, I'm going to subtract 4. Wait, did you say I didn't even
Six,
write down what you told me. 6 and a
six
fifth
and
minus
3 4/5.
3 and 4 fifths. Okay,
Yep.
yeah. So I'm going to subtract 4.
Okay.
So I'm going to get 2 and a fifth. And then the next thing I'm thinking about is how far away are that 3 and 4 fifths and that 4 that I already subtracted.
Mm-hmm.
And I subtracted 1/5 too much.
Okay.
So I'm going to add back 1/5. And so I have 2 and 2 fifths.
Because 2 1/5 and one more fifth is 2
Mm-hmm.
2/5. Yeah.
Mm-hmm.
Okay, cool. When you just did that, when I gave you the problem 6 1/5 minus 3 4/5,
Mm-hmm.
you had to come up with your own helper.
I
How
did.
did you come up with the helper of 4?
Because I thought if I could subtract a little bit extra, a little bit too much, I didn't really want to think about. I mean, I guess I could have subtracted 3 and then 4 fifths, but I
Mm-hmm.
really do tend to like over
Well, especially
because
because,
adding back. We just did some work with that, but adding
yeah,
back a fifth is pretty nice.
and like you said, we had just done work where I kind of had gotten your brain and hopefully everybody
Mm-hmm.
I'd high dosed everybody in the
Mm-hmm.
podcast with this idea of subtracting a bit too much.
Mm-hmm.
And then you could just kind of
Mm-hmm.
adjust from there.
Yeah.
So what you just did, and if anybody was actually doing the mental actions of solving these problems as we were going, is you were developing senses of place value and
Mm-hmm.
nearness and neighborhood and how things are related and how you can adjust. All very mathy kinds of things that we need students to do as they're developing additive reasoning and more.
Pam, I'm sitting here thinking about what
Yeah.
somebody would be taught to do in class for
that's
6 and a fifth.
that's where we're going right
Okay. All
now.
right. Okay. Sorry.
Well, I want to do the whole numbers first, and then we'll go to
Yeah.
fractions.
Okay.
So, Kim, everybody on the podcast, one of the problems that I asked you to solve was 563 minus 295.
Mhm.
You chose to solve it by thinking about 563 minus 300
Mhm.
and then adjusting 5 up. But
Mhm.
what if I was trapped in the algorithm?
Mhm.
So if I write down 563
Mhm.
line,
Mm.
little subtraction symbol, 295 big line, then what am I
Mm.
supposed to do? I'm supposed to start from the least consequential numbers in the problem, right? Not the 500 and the 200 or 500 and almost 300. Not that. No. But I'm going to start with the least consequential numbers, which are the end 3 and 5. 563, that 3,
Mhm.
295, that 5. And I can't now, then I say to myself, 3 minus 5. Whoops, can't do that. So
Eh.
now I've got to like turn that 3 into 13 because I grabbed a 10 from the 60 or maybe just a 1 from the 6.
Mhm.
That leaves me a 5 or a 50, depending on if you're thinking about place value. So complicated right now. Then I can think about 13 minus 5. So I've borrowed or regrouped. I now have a 13 minus 5. Could you agree with me that if I'm a student that's mimicking these steps of the algorithm, at this point, I could say to myself, 13 minus 5. Ready, begin. 13, 12, 11, 10. And I could literally count back. If you can't see me, but my fingers are popping up and I'm counting back 5. There's a
Mhm.
couple different ways to count back, but either way, I'm counting by ones and I end with 8 and I write down an 8.
Mhm.
And then I go over where I borrowed the sugar from next door or however that dumb thing goes. And now I've got 5 minus 9. Oh, crumb. So now I've got to
Mhm.
make that into 15, borrow from the 5 next to it or regroup, however y'all, the words don't matter so much because I'm just performing mimicking a bunch of steps. So now I've got 15 minus 9. Could you agree with me that I could go 15, 14, 13, 12, blah, 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 blah. I could count by ones and I could get that correct. And I could then continue counting by ones, get the entire subtraction problem correct. My teacher could say, yay, you've got subtraction down. You are thinking additively about subtraction. You're an additive reasoner. You're reasoning about subtraction. Sweet. When in reality, I was using less sophisticated reasoning, counting by ones.
Mhm.
But maybe today's focus, so that was a last week's focus. I'm using less sophisticated reasoning than problems are intended to develop. But notice that the only problems I ever solved were things like 13 minus 5, 15 minus 9, and then I would end with 4 minus 2. They were always either single digit minus single digit or teens minus single digit.
Right.
If I'm stuck in the algorithm, I will never, ever do anything more than digit stuff. Maybe
Right.
the max will be teens minus a digit,
Right.
and I can count by ones.
Mhm.
The algorithms trap students into a digit-oriented focus
Mhm.
where the numbers are pulled apart and I'm only dealing with just a bunch of digits. And I don't
Mhm.
ever think about those bigger relationships that you were talking about earlier, like 274 minus 100 or 563 minus 300, or
Right.
we can get
Right.
to the fractions now, 8 1/4 minus 5. Or the last one that we did, 6 1/5 minus 4. Like, we don't ever have kids reasoning about those sort of bigger kind of ish numbers. We don't have thank you, Joe Bowler. We don't have kids. We haven't high dosed them enough to invite them to grapple with those numbers in a meaningful, what ish round kind of way
Right.
to reason
Right.
about them. Yeah. Well, you were
Yeah.
going to say something earlier about the fractions. Do you remember what it was?
Yeah, I was when I wrote down the problem, I wrote, when I wrote 6 1/5 minus 3 4/5,
Uh-huh.
I started kind of reminiscing about what many kids would have been asked to do. And, I'm assuming that that's change it to an improper fraction to then subtract.
That could definitely be one way of doing that.
Yeah.
Uh-huh. Yeah. Another way. So if we change both of those into improper fractions, then we would end up with a numerator and a denominator where we would it would have the common denominators. We would
Hmm.
just subtract the numerators. And
Hmm.
when we subtract, and I haven't done it, so I'd have to,
Well,
what is
let
it,
me tell you what the
30?
numbers would be.
Is it 31 and
31/5 and 19/5. So then you're subtracting 31 minus 19.
probably from a digit oriented
Right.
perspective, right?
Right.
Yeah.
Right.
Yep. Or I might say to myself, instead of 6 1/5, I'm going to regroup and turn that into 5 6/5
Right.
minus 3 4/5. And then I might just do 6 minus 4 and 5 minus 3 and never, and always only be thinking about digits.
Correct.
Trapped in this digit perspective.
And
Teachers. Oh, you do your and first, and
I
then
was
I'll
going to
do my
say,
teachers.
and when you're only thinking about digits, you have no idea when you look up if it's even close.
Yeah, you're kind of reading off the
Mhm.
answer.
Yeah.
You're not, yeah, like you said before, when you did, I don't remember which problem it was, like 563 minus 300, you're already clear, kind of, oh, I think that was the last, anyway. If you're doing 563 minus 295, and you think about it as 563 minus 300, you're already in the ballpark.
Right.
You already have an ish, that's a way of thinking about an ish number. And we're high dosing kids with this over pattern. So they have a strategy for thinking about that. They're already partially reasonable. Teachers, you know how many times you've said to your students, oh my gosh, your answer isn't even reasonable.
Yes.
I invite you to consider it's because we took them out of reasoning land.
Right.
And we put them into a digit focused set of steps to mimic. And they did the stuff with the digits,
Right.
and it's not that they're unwilling to wonder if their answer is reasonable. We haven't helped their brain grow so that their brain can think of whether their answer is reasonable. And how do we help their brain grow? By doing problem strings like we just did, where kids are actually invited to grapple with their relationships in a way that gives them the strategies with which to do it. We don't just leave them. We don't just go, hey, everybody, go find your ish number. Good luck.
Yeah.
Come on, do it. Like, go. Too many kids, probably including me, wouldn't have a strategy until we high dose them with the major patterns and relationships so that they go, oh, I could just go a little over. And then now I have a good ish number. Yeah.
Yeah.
All right. So one of the traps of the algorithms is digit oriented focus, where students aren't actually reasoning about what the problems are asking to reason for. Bam. Like I did in the last episode, I invite you to consider, do you have an algorithm that you're like, this one doesn't. Secondary teachers, it's not always digits, but it's parsing out the problem into too many pieces so that I never consider the whole. So if you're thinking about an algorithm that involves polynomials, consider, does it break the polynomial into the terms? And I never think about the entire polynomial. I only think about terms, and maybe even the coefficient and the variable in the term. So it's not just digits, but it's kind of breaking the problem into pieces and parts and doing stuff with the pieces and parts and then reading off the answer at the end. That's the same. When I refer to a digit trap, I'm also referring to a trap that includes parts like that, breaking the thing into pieces.
Yeah.
All right, y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Hey, listeners, don't forget, go to mathisfigureoutable.com/book-launch to register for the free Developing Mathematical Reasoning, Avoiding the Trap of Algorithms book launch webinar taking place on March 18th. Y'all, I'm going to be there. It's going to be cool. You do not want to miss this. Totally free. Come join us. mathisfigureoutable.com/book-launch. We'll see you there.